Okay, so now on to anti-relativity lesson 4, coordinates. So there are lessons in special relativity, and the aim here is to counteract that and give lessons in anti-relativity. And the way to do that is to point out what is being taught in relativity lessons is nonsense. Over the years, the teaching of special relativity has been to pile on more nonsense, and that includes to rest of relativity when it goes to general relativity. So they're going to contrast how the teaching has changed. Taking an example is a relativity book from 1982, which got updated in 1991. So this is the book Introduction to Special Relativity by Wolfgang Windler, and you're supposed to be able to learn relativity from this book, presumably after you've studied classical physics and so forth. You would then move on to learning relativity from this book. And so going with the second edition of the book and pointing out when it's different to the first edition. And so the method they're using is to move goalposts, and that is to make changes to things. And the changes they make is just piling on more nonsense. So edition 2 of the book, after it got updated, in section 5 gets to coordinates, the relativity of time. And it says an event is an instantaneous point occurrence, like the collision of two particles or the flash of a flashbulb. It will therefore be specified by 4 coordinates, 1 of time and 3 of position, e.g. t representing time, x, and y and z representing certain distances. In special relativity, events play a central role, and we must be clear how to assign coordinates to them, at least conceptually. So my note on that is a point occurrence, so dealing with points and dealing with points in 4-dimensional coordinate system, which are called events. The book carries on. It says the standard spatial coordinates for inertial frames are orthonormal Cartesian coordinates x, y, z. To assign these to events, the presiding observer at the origin of an inertial frame needs to be equipped only with a standard clock, e.g. one based on the vibrations of the cesium atom, thiazolite, and a means of emitting and receiving light signals. So basically he's using a measuring rod and a clock. So a clock based on vibrations of the cesium atom is meaning an atomic clock. And the relativistic effects are very small on an everyday cell, so need a very accurate clock. Presumably he's talking about a very specific type of clock that can show these very small relativistic effects. So the book carries on. It says he, which is the observer, will also need an agreed standard of length, e.g. a meter stick, or the wavelength of a specific atomic emission line, at least in order to assign a numerical value to the speed of light once and for all. And that's speed of light c in vacuum, free of the influence of fields. Anyway, the meter distance is now defined in terms of light as per Wikipedia. So light travels a certain distance in a certain time, and that's supposed to be a meter, and it's defined that way. So it all ends up very circular. Light speed used to define distance, and distances will be pointed out is supposed to change and on. That's the context of special relativity and so forth. That raises the issue of what if had speed of light in vacuum c changing instead of keeping it constant and keeping the unit distance measurement constant instead. But that question won't be dealt with by most relativity texts, so they're just leaving things ambiguous there. So the book carries on and says, in accordance with the law of light propagation, he, that's the observer, can then measure the distance of any particle at which an event may be occurring by the radar method of bouncing light echo off that particle and multiplying the elapsed time by half c. And the book's not explaining where that half c is coming from. So once again, it's leaving things ambiguous. It carries on and says, angle measurements with the theodolite on the returning light signal will serve to determine the relevant, and that's relevant things at x, y, and z once a set of coordinate directions have been chosen. The same signal can be used to determine the time t of the reflection event at the particle as the average of the time of emission and the time of reception. The book carries on and says, but conceptually it is preferable to pre-coordinatize the frame and to read off the coordinates of all events locally. For this purpose we imagine standard clocks placed at rest at the vertices, and it's got analysis m epsilon, n epsilon and p epsilon of an arbitrary finite lattice where m, n and p run over the integers and epsilon is arbitrary small. The spatial coordinates of these clocks can be determined once and for all by the origin observer, meaning the observer at the origin, and then engraved upon them. To synchronize the clocks, it is sufficient to emit a single light signal from the origin, say at time t subscript 0. Each lattice clock is set to read t subscript 0 plus r divided by c as the signal passes it, where r is its distance from the origin. An event is then coordinatized by noting the time and space coordinates, which are t, x, y and z on the clock nearest to it. And it doesn't say if other clock synchronization methods are possible, so it's once again leaving things ambiguous. So the book says, in view of our remarks at the end of the last section about the dispensability of the law of light propagation as an axiom, it will be well to point out that identical coordinates can be assigned without the use of light signals, though perhaps less conventionally. You wonder what that means. Anyway, edition 1 Stesson said, in view of the disparaging remarks we have made about the law of light propagation at the end of the last section, it would be well to point out that identical coordinates can be assigned without the use of light signals, though perhaps less conventionally. So the major change is to drop the word disparaging in the revision. The issue becomes, what did Rindler think was disparaging in the end of the last section? I have looked back and don't know. What was being said was mostly nonsense as far as I'm concerned, but it did not seem to be disparaged. Anyway, Rindler in the revision thought it best to no longer call it disparaging. The thinking process of Rindler for those changes, of course, not revealed. So edition 2 continues. For example, the basic lattice could be laid out with rigid scales of equal length epsilon, and the vertex clocks could be synchronized by a sound signal from the origin if the frame were filled with still air, or by rifle bullets of known velocity shot from the origin in all directions at time t subscript 0. Same thing as it said in edition 1, but he's not really going into enough details here. It's just doesn't make many sense. So edition 2 continues. It is clear that if there exists a time in terms of which the physics in the frame is isotropic, our above methods have determined it, since they are based on the isotropic propagation of light, sound, rifle bullets, or whatever. The same thing said in edition 1, and it still doesn't make anything clearer as far as I'm concerned. Anyway, carrying on, edition 2, it says in classical kinematics, the preceding observer of a second frame, S prime, passing through S, could save himself the trouble of independently calibrating his frame by simply setting his standard lattice clocks to coincide with any S clock they happen to pass, and engraving on his clocks the X, Y, Z of the S clocks they pass at one instant, say at t equals 0. And so edition 1 says things differently. Now in classical kinematics, the preceding observer of second frame S prime passing through S could save himself the trouble of independent calibration by simply copying on his lattice clocks the T, X, Y, Z of the S clocks with which they momentarily coincide at some instant in S. By classical kinematics must mean Newtonian physics. So he's talking about a situation which is Newtonian physics. Edition 2 carries on. Not so in relativity. Adoption of S time in S prime would lead to anisotropic physics, among other troubles. And edition 1 says the same. So by relativity must mean special relativity, thus talking about special relativity situation as opposed to what was a Newtonian situation earlier. It's just all ambiguous. Edition 2 carries on. The root of this difference can be traced to the second axiom. And edition 1 says the same. So the issue becomes how get from the second axiom to the just stated special relativity situation. And in my view, the attempt to next do that is inadequate. And so, edition 2 carries on. He says, consider an xt space-time diagram on which to plot events occurring on the x-axis of S. And you see fig 2. Edition 1 says consider an xt space-time diagram on which to plot events occurring on the x-axis of X, and see fig 3. So edition 2 has changed the numbering of the diagrams. This is the edition 2 diagram, and this is edition 1 diagram. Make of it whatever you will. Edition 2 carries on. It says, let A and B be lattice clocks on the axis equidistant from the origin observer O. Now suppose the origin observer O prime of S prime moves along the x-axis of S, passing O at t equals 0, and suppose its lattice clocks A prime B prime equidistant from O prime pass A, B respectively at t equals 0. Suppose further that the control light signal of O was emitted, say at t was t subscript 0, so as to pass A and B at t equals 0. In our diagram, photon tracks have slope plus or minus 1. We have chosen the units of time and distance so as to make c equals 1. And that's a sort of convention to make it 1 unit distance travelled in a certain time. And so without loss of generality, we can assume that O prime emits his control signals at the time t prime subscript 0, when the signal of O passes him. A lot of things are being assumed there without explaining how they can be assumed. It's all just a mess. Edition 2 and the same in edition 1 carries on and says, it is then clear from the diagrams that the signal from O prime while reaching the coincident clocks A and A prime will not reach B prime until after it has passed B. So A prime and B prime must read different times when they pass A and B, which shows that O prime cannot adopt the time of O. In fact, we have demonstrated the relativity of simultaneity, whereas the events of A prime and B prime coinciding are simultaneous in S, they are not simultaneous in S prime. And it's all just another confusing mess. But presumably is given footnote to try to clarify things. The footnote is in the next slide. Edition 2 and edition 1 gives this footnote. Note how the property of the use by O and O prime of the same photon to synchronize their respective clocks A and A prime depends crucially on the law of light propagation. No sound signal could be so used since sound propagates isotropically only in the rest frame of its medium, but the vacuum has no rest frame. And it's putting that as a quote from Lindquist. The quote being from Lindquist that the vacuum has no rest frame. But that's all making just things more confusing. It's just a mess to make the claim that the vacuum has no rest frame because it has no medium for sound. That's just a mess. There's no such thing as a perfect vacuum. So go for instance this from encyclopedia about vacuum. It explains to you there isn't a perfect vacuum. Thus when the term vacuum is used, it does not refer to a perfect vacuum, which would be a total absence of matter. Instead, vacuum refers to when there's a low amount of matter, but not zero. So what's it talking about? Vacuum. So back to this claim, we'll read it out, don't want to read it out again. It's this quote by this Lindquist person. He's supposed to be saying the vacuum has no rest frame. But the idea that sound propagates in a medium is okay. But when the term vacuum is used, there is still an amount of medium, matter in it, that the sound can travel through. Admittedly, the less medium matter, the less the sound, but there's never zero matter. Thus there is a rest frame for sound in a vacuum, and the claim that there isn't is false. Presumably it means no sound propagated in a perfect vacuum, but that is an idealized case that never happens and is physically unrealistic. We can then see how claims are linked together that are false. He's just making links between different false claims. Rindler cites Lindquist for the quote, the vacuum has no rest frame, but gives no more information of where Lindquist said that. So I checked with artificial intelligence, ChatGPT, and it says the relevant Lindquist was probably Richard W. Lindquist, but he never said that. That quote is never said by him. If the artificial intelligence is correct, And so I asked it, going with the claim the vacuum has no rest frame sounds nonsense, and AI ChatGPT agrees. I put it as a question. The phrase the vacuum has no rest frame makes no sense because there is no perfect vacuum. And ChatGPT said, exactly, as that's a very sharp and philosophically important observation. You're right, the phrase the vacuum has no rest frame assumes something self-contradictory, because a vacuum in the physical sense isn't a concrete entity that could have or lack a state of motion. So everything that Rindler is saying is just total nonsense. He needs to go into further explanation, and he's not doing that. But the book carries on. It says this detailed example has been given to prepare the reader for the surprises in store when presently we derive the exact relations between the coordinates of two frames. And I've pointed out what Rindler said is nonsense. So it can't prepare the reader for what's coming next. And it's typically what relativity texts do, namely talk nonsense. Rindler is just another example of relativity text talking nonsense, and there are numerous ones like it, talking nonsense.